Hi everyone. So in this class or in this session we are going to discuss about the lumped heat analysis, systems. So before that we should understand some basic things. So what is steady state heat conduction and unsteady state heat conduction? So the unsteady state heat conduction, steady state conduction nothing but the temperature does not change with the time, and unsteady state the temperature changes with the time. So now we are going to quick recall about some basics about heat unsteady state heat conductions. So the example for the unsteady state heat conductions are cooling towers in IC engines, cooling automobile engines, boiler tubes, rocket engines, etc. etc. So this unsteady state heat conduction is classified into two categories. One is called periodic heat flow and non-periodic heat flow. So periodic means it varies with the regular basis. Temperature of the substances varies with the regular basis. Here the temperature at any point varies with the linearly with the time. So this is called as non-periodic flow heat transfers. So before going to lumped analyzed system, a Dimel's number is called as a Dimel's number called Biot number is very important. So the Biot number decides what type of analysis takes place in the heat transfer system. So Biot number is nothing but that is the ratio between the internal heat resistance to the surface convection resistance. So this is called as Biot number. So mathematically we can say that Bi is equal to HLC by K, where H is nothing but convective heat transfer coefficient and LC is nothing but characteristics length, where K is thermal conductivity of the material. So it is denoted by the letter Bi. So it is so this is the Bi. Biot number Bi is equal to HLC by K, where H is equal to convective, K is the thermal conductivity of the material. Thermal conductivity is nothing but the ability of the material to conduct the heat is called as thermal conductivity. Okay. LC is nothing but characteristics length. It may be defined as the ratio between the volume and the surface area is called as characteristics length. Now we will see about the lumped heat analysis. So lumped heat analysis is also called as internal resistance is negligible. So I mean that there is no internally resistance material inside present in the material, because so it means that there is 100% heat transference takes place. So the process in which the internal resistance is assumed as negligible is called as lumped heat analysis, or it is also called as Newtonian heating or cooling process. So in Newton heating or cooling process, the temperature is to be uniform at the given time. Such analysis is called as lumped parameter analysis. So there is an equivalent formula, that is nothing but convective heat loss is equal to rate of change of internal energy. So there is a mathematical relations between the convective heat loss and rate of change in the internal energy. So for lumped analysis system, Biot number is always less than 1. So when you are going to calculate the Biot number for the particular heat transfer process, the value lies below 0.1. That type of system is called as lumped system analysis. Suppose the value is more than 0.1, the temperature gradient exists. That means dt by dx will be available. So now we will move, but that particular conditions we will move to transient conduction analysis. So there is a mathematical formula or energy balance equation for, or the governing equation for the process is heat lost by the body is equal to decrease in internal energy. That is, I already told about this. That is a convective heat loss is equal to rate of change of internal energy. So mathematically we can say that rho Vcp dt by dt is equal to minus HA into dt by dx. So this is the mathematical relations of lumped heat analysis, where the T is temperature at a given time and Ti is the initial temperature of the surfaces, T infinity is the fluid temperature or the surrounding temperature, rho will be the density, Cp will be the specific heat, and A is the surface area and V will be the volume. and we will see about some applications and advantages of lumped heat analysis. So, application cooling of hot metal parts and heating of cannon food, electronic device cooling, automotive engine components, and battery thermal management. So, the lumped analysis playing these areas crucially, and some advantages are simple mathematical model, and easily can be able to calculate the heat transfer or heat loss, less computational time, we can quickly calculate the rate of heat transfer, suitable for small objects and widely used in the engineering designs. So limitations, when you're going to see about the limitations of lumped analysis, it will be used only for the Biot number will be less than 0.1, and it is not suitable uh, for thick or poorly conducting material, and it ignores internal temperature gradients, cannot predict temperature distribution inside the object. And, we can summarize the above points. Lumped heat analysis simplifies the transient heat transfer, assumes uniform temperature throughout the body, and the biotimer determines its applicability. It is widely used for analyzing the heating and cooling of small engineering components. Thank you.